Okay. All right. Good morning and welcome to the class. My name is Bhuvan Manhelkar. I'm presenting IT Program Design. So the whole discussion is around design rather than programming. And as you are aware, we have added, we have had a taste of 14 different UML diagrams. So in this sort of brief introduction, I just want you to, I want to take you guys through these diagrams and how they are used. But while I do that, I also want to update you on the project work, because it seems that the project work is the one that could be confusing or may not have all the details in Canvas. So if you remember, there are 14 diagrams, right? Do you remember the names of some of them?
Use sequence activity.
Not all, Scott. I know. You are an A+ student. Well, all students are A+.
That's it. That's all I know.
So
System.
Yes, fair enough.
Activity.
Activity diagram. Any diagram that comes to your mind?
The
Class diagram, which is a structural diagram. Activity
Package.
diagram is a behavioral diagram. Any other version? Object diagram is it's a in-memory diagram. And as we know, the difference between a class and an object, very important. Am I a class or an object?
Object.
See, I told you guys are A+. Because I am an instance of a class called teacher. And before we started doing modeling in the problem space, all the work we, the IT community, did was directly in the solution phase. You remember 3 spaces: problem space, solution space, and background space. And we distributed the diagrams according to the value they bring in the problem, solution, and background space. Now, if you don't remember, that's fine. Very simply, 14 diagrams are not used in practice by a professional when they do their work. If I am a programmer, I start with class, because that's the representation of my program. But if I am a business analyst, the requirements modeler, I start with use cases, because that's the bridge between my user and I. And software programming projects, as we appreciate, are massive, and no one programmer or no one set of skills are enough. So we need all kinds of skills. What are those skills? Capturing requirements, right? What is it that my user wants? Use cases, activity diagrams are key mechanisms to capture what my user wants. What is it that I am designing? My solution. Class diagrams, sequence diagrams, state diagrams are key mechanisms to design a solution. So if I'm a designer, I'm focusing on those diagrams. If I'm a business analyst, I'm focusing on use case diagrams and activity diagrams. Now, can I, as a programmer, completely avoid use case diagrams? No. I need to be able to appreciate these diagrams. Use cases, activities, flowcharts, I need to be able to appreciate. But I may not be drawing them. The business analyst is drawing them. So if you faintly recollect, I've given a table with the 13 diagrams listed, and I have said problem space, solution space, background space, and then I have given star ratings to those diagrams. This was the work I and my colleagues did way back in Australia. And UML is 1997 official, so it's now almost 20 years. And a lot of work has gone. And one of the contributions, even those articles demystifying the UML, that I have put up already, which are there in your folder, I know, have got these star ratings. Then there is a architectural role in system design. See, your program is not going to sit alone as a solution. It is going to be a part of many other applications and web services and mobile apps and so on. Someone has a job to decide where will your solution sit in this whole 100 set of apps. So someone in the background does that thinking. And someone decides how this solution will be deployed. That's the architect. So someone will say this component of my solution will run on the server. And that component of my solution will run on the mobile device. That is called deployment. And there is only one hardware diagram in UML called deployment diagram. It's in the background space. There is one diagram that brings all the classes together in a set of components called component diagram in the background space. So I want you in this class to appreciate these diagrams, but I want you to know that in practice you will be using the diagrams that are specific to your program. And then somewhere in module 12 or 13 or 14, I forget now, I have included quality assurance and test. So you need to give some thoughts to the test data, valid set of data, invalid set of data, walkthroughs, inspections. You need to get a taste of it. Then what you produce will be a high quality design and therefore a high quality program. That's like my opening statement of what we are doing in this course. In the very first or second module, I asked you to go through these 14 diagrams. And then in the remaining modules, we are going deeper and deeper into each of them. And I'll show how we use them. They are all related to each of them. Each diagram adds value to my work. And I have not just taught this, I have also practiced it in banks, in insurance companies, in travel agencies. Those case studies that I have produced, the insurance company and the travel and the farm are all some real client or other. And these books are just to support that. I'm creating a new version. You can have a look at these books also in the channel. Are containing all the use cases and all the design. It's a fascinating field. It is meant to provide immense value to programming work. Any questions or any thoughts? If you are sent into a real life organization as a programmer, you might feel that the first thing you have to do is program, because you are called a programmer. But we got some guys from defense, right? If you are taught how to shoot, that's not the only thing you do, right?
Well, I worked in engineering.
Okay.
I was not on the front lines.
Let's talk about engineering. I'm an electronic engineer. And I am from the era where diodes and triodes were physical devices that could be seen. There is so much around it to make it work. It cannot be one discipline. I mean, you talk about engineering. I mean, how valuable is engineering? the whole thing can't function without engineering, right?
Yeah.
You talk about medicine and health associated with veterans, with defense, and defense cannot function without medicine, right? If we go to our IT example, we are programmers. No, we are not just programmers. We need to be able to design, we need to be able to listen. In some of my face-to-face courses, I have actually emphasized on the art of listening and the art of questioning. I am right now in Sarasota talking to a very small health and fitness company that wants me to help them with a mobile app. They want a mobile app on iPhone and Android. And half the time I am sitting with them over a cup of coffee about their requirements. What do you want? Oh, I want this and this and this. Okay. Now I'll go create a mock-up and go back to them, and the whole requirements have changed. Right? Now, if I was to take the requirements given the first time and go ahead and produce the greatest code on earth,
Wow.
and show them the mobile app, and they say, that's not what I meant, how much of loss my company is in, right? So I want you to understand that that's the background with which we are discussing here. Okay. So if you haven't got any other questions, we'll move to how these diagrams fit in with each other. And I'll give you a taste of each of them. And that REC is still on. Okay. Now, you're given a requirement. You're given insurance and travel and park. These are the three case studies that we have. So let's not take any of these three case studies. Let's take banking. Will banking work? Or let's take health. Let's take health, because health is the example I'm using in the course as well. You are asked to go as a team to Sarasota Health, Sarasota Hospital, and you have to put together a new solution, software solution. What is the starting point? You are a team of 3, or let's say 10 or even 30 consultants. You belong to one of these large consulting companies, and you have been contracted with $25 million budget and 1.5 years time, and you have just finished your IT program design course, so you are well equipped with modeling techniques. What is the first thing that comes to your mind?
Want to know what the problem is, right?
Awesome, right. There's absolutely no doubt about it. So really we are saying business problem. My handwriting has never improved. I'll try. And that is going to be a set of iterations, right? Now, when you are going deeper into finding out what is the business problem, and it's a health domain, what kind of answers do you expect? Or where will you direct your interviews, your requirements, whatever it is?
Who's interfacing with the system?
Right? So that's a absolute spot on answer. This is going to lead to a patient. Nowadays we call everybody customers, but I'll call them patient. And we will have doctor, and we'll probably have administrator, right? Very simple. Who are the users of this solution? You are asking us to build a solution. We are happy to build it for you, but we will not work from solution to problem. We will work from problem to solution. Your problem is You don't have a sophisticated mechanism to register patients, to provide appointments, to put the patients and the doctors together in the most efficient way. Nursing schedule is on a whiteboard, so nurses don't know when it has changed. Those are the problems we are talking about. And the billing. Half the patients are billed twice and the other half are not billed. This is the CEO of a hospital talking to you. And you will start with this. Right? What is the logical next step?
What do they need to be able to do?
Right? What is it that I want a patient to do? What is a doctor going to look for in this solution? Okay, a doctor is, I need to know how many patients I'm going to examine today, and how many I'll examine tomorrow. And the patient wants to know which doctor am I going to see? So what's my disease? Like, am I going to a gynec, or I'm going to a pediatric, or I'm going to a ortho? Right? Well, I'm just having cough and cold, and I just need to see my GP, as we call it, general practice. So there will be a series of interactions. Now you can almost note this down. It's given in the note, but a series of interactions between the actor and the solution. And we actually create a boundary like this. And in that boundary, we draw ellipses. And we give a name to these ellipses, such as schedule, appointment, query, prescription, and something else. I'm not too worried about the exact business process, because you know more about travel than I will ever know, or he knows more about system admin and how the schools work than I will ever know. So please don't worry about how actually a hospital works, because we are not studying how a hospital works.
This is like high level concept.
And it's the diagrams that I want you to study, rather than the contents of the diagram. But without the contents, we can't study. That's why we have to have a content.
Just a general depiction of how things connect.
Yes. And then we draw lines somewhere from here to there, and those lines have got some rules. For example, and with an actor and use cases, I am going to recommend simple lines. In UML, you will find rich set of notation. There are lines with an arrowhead, lines with two arrowheads, and all of that. Very simple. And if we have to schedule an appointment with a doctor, and we have to make a query, our patient actor wants to do this. Maybe both of these require the patient actor to log in. Now login is low level. High level will be prove your identity. So let's stay at login level. It's easier to understand. And I draw another little ellipse called identify or login. Identify. And here I'm saying whenever I schedule an appointment, it includes login. Whenever I want to query a presentation, it includes login. Okay. So there is no include between an actor and a use case, but there is a include between two use cases, because one includes the other. Now, if you have done programming, and some of you have done courses, and some of you are tutors as well, you have a subroutine. You have a program that includes another program. Here, the requirement includes another one. And you want to provide some description. These are called notes. I have explained to you actors, system boundary, use cases, use case relationships, and nodes, which all makes a use case diagram.
So all the use cases would get and include on the login, even if the login is the first thing that you do. If you're accessing the portal, and then you've accessed applications within the portal, they are all included in the login.
And therefore, this is not a flowchart. This is not a flowchart. My mistakes, I'm going to share with you 20 years of UML mistakes. First thing when I learned use case diagram, I thought this is a flowchart. And then I would say, how come login appears after schedule? But use cases have come about through Ivar Jakobsen's great work in use cases in 1992-93. Jakobsen spelled Jakobsen. And this was object oriented. And object orientation has improved. One last thing with use cases. This is a diagram, and in the discussion question I have asked, Martin Fowler says this is a visual table of content. Why? He says this is going to take maybe 15-20% of a business analyst effort. So the question arises, where is the remaining 80% effort?
The use case documentation.
So two things. One, use case documentation, which means now this is not a part of the UML diagram, but if you look at this use case, it's actually a Word document, and I've given you the shell for the Word document. Or it can be directly documented in the case view. This can be drawn in star UML, and I will draw it for you. But you can go inside the use case, double click or right click or whatever.
Is that where you put the notes?
Not these notes, because these are on the diagram,
in there.
but the description of a use case. That's major chunk of your 80%. Now, let's take a patient who wants to schedule an appointment. Patient identifies herself, system validates, so that you can log in out of. We can always draw another use case diagram which deals with login. Patient says, I want to see a gynecologist. So system says there are 3 gynecologists available in my hospital. Patient says I want to see Dr. Jones and clicks on Dr. Jones. System provides available time slots for Dr. Jones. 1 week from now in the morning at 9 a.m. and 3 weeks from now in the afternoon at 2 p.m. and whatever. Then the patient selects 9 a.m. a week from now. And the system confirms the appointment. What we have done? What did I describe right now? I described the documentation of a use case. We can insert admin in between, but basically a use case is an interaction between the actor and the system. So let's try and put it in my handwriting. So you know, in the use case documentation there will be a list of actors, name of the use case, and all the other things that go with it and precondition. But then there are these statements. So patient identifies herself, system validates ID, patient specifies doctor type, system displays available doctors, then patient selects doctor, then system displays available time slots, and so on. That's your use case interaction. And that's very important. We need to be able to write it properly. But we can also draw a picture because this is like a flow chart, isn't it? Let's take this forward. We start and we say patient identifies herself, and we have got a slot here which says system validates, and then we will have a decision point in which is this a valid patient or not. Valid patient, yes. Patient asks for specializations. System provides list of gynacs. I wouldn't write gynac here, but provide a list of specific to what the applicant has asked for. Selects doctor, provides appointment, selects the appointment and the use case variations.
I have a question.
Please.
This looks like to me a sequence diagram.
Well, good question. Hold on to the question. The question here is, for my other friends who are not here, this looks like a sequence diagram. And the reason is because it is actually showing a sequence. So you feel that it is a sequence diagram. So your feeling is not wrong. But it's a flow chart. It is also a flow chart. That's the other feeling you are getting. The reason why we don't call this sequence diagram and we have another sequence diagram, because this is a generic flow, whereas a sequence diagram is an instance level diagram. Here, we don't have any objects. There are no objects on an activity diagram. But all the elements that appear in a sequence diagram, which we have not yet studied, will be objects. So there will be a patient and there will be a doctor on a sequence diagram. This is the patient, the doctor. It's not even the, it's just patient and doctor. Singular, common nouns are appearing here. Whereas specific nouns or anonymous but specific, that is a doctor, a teacher, a patient appear in sequence diagram. Yes, sir.
I have a question. Since we're on activity diagrams, in documentation that we read this past chapter, I noticed that when there's multiple swim lanes, some, I know they're not objects, but activity uses are within the boundaries of the swim lanes, some exist in both. What is the significance of ones that cross over swim lanes?
Right. Now, to answer this question, let me annotate this diagram further. I will have a patient, I will have a system, or I might have the system over here and I might have admin in between. Now, this is the difference between a flow chart and an activity diagram. Because an activity diagram is dividing the activities around the actors. In a flow chart, we just draw a flow chart. So we just added a bit more value to the flow chart by saying, now if I have to test this activity diagram, my testing becomes easy. think why. Everything related to patient is in one swim lane. These were called swim lanes. I'm still answering your question.
Okay.
I'm still answering the question. So these are called swim lanes. Now they are called partitions. Small value two. UML 1.4 had swim lanes or whatever, and then 2.1 has got partition. So it is helping me organize my requirements. We are still in the problem space. We haven't gone down to programming yet. So now, to answer Scott's question, there could be some activities like select a doctor. That requires not just patient but also a bit of admin, because maybe the patient needs to phone the admin to find out, is this actually, there are two Dr. Jones listed, and is this the one that I'm looking for, whatever it might be. So if I have got my admin swim lane here, which is a bad way of doing this, then my selection is actually going to go across both. Now, this is the difference between purist and a practitioner like me. The purist will say an activity has to be in one swim lane, and I more or less agree. But I just find that there is an activity where someone else is also involved. If I have to remain a purist, then I will say I put the activity in the main or the primary actor's swim lane.
Can we do that? Okay.
Yes. No issues.
Well, I was going to say, I mean, a purist would say, okay, for diagram purposes, this is how it should work. Practitioner, a real world situation, you'll have these things crossing different lanes
Yes.
in real practice.
Yes. And one of the nicest comments I have heard from the gurus, I won't name them because it's on camera, but the guru has said that use case diagrams, use cases, and activity diagrams don't compile, right? And that makes sense to me. They don't compile like class diagrams. That means precision in terms of like at programming level is not the goal of problem space, but enhancing the dialogue with the user is the goal of problem space. So I wouldn't worry too much unless I have asked you a question that precisely says, include, is this include or extend? Then you got to know, is include or extend. But otherwise, this kind of a diagram is great. The only addition now that I'm discussing this diagram to a flowchart is something called a sync point. There's a bar there, and then you can have two activities, and then they meet, and then there is another bar, and then a third activity starts. This is called parallel activities. If you remember old flowcharts, we always had a sequential flow of activities. We could not show two activities in parallel. But in this diagram, we can. And that is our key to optimizing business processes. Okay, a nurse is checking out the patient. So the doctor doesn't have to wait. The doctor could be doing something else. Then the doctor finishes her job. The nurse finishes examining this patient while the doctor was doing something else. Both tasks have finished. The doctor can now examine this particular patient. Martin Fowler in UML Distilled, very well read, very popular book, talks about making a cup of coffee. Like you're boiling, it's instant coffee, so you're pouring your coffee powder in your cup, which takes only 5 seconds, but the boiling of the pot takes 2 minutes. But both activities are going on in parallel, and then when both are finished, then you pour water and coffee in your drink.
Be useful for cooking. You usually have a lot of stuff going on at the same time.
Like these parallel processes. Alright, so I have covered two diagrams in detail in the time that I had given myself for about 6 diagrams, but I will explain to you other couple of diagrams as well. If you, should I just leave this here or I can rub this? Oh, I'll go. I'll move. Do you think you can move the camera slightly on this side, Maurice? So I can draw a couple of more diagrams here, and that way you still have that as a reference, and you might take a couple of pictures. Okay. Now I have my documentation. Is REC on? Okay. Awesome. I got my documentation of my use case. I have validated through activity diagram. It's a good looking set of requirements. I can easily have 5, 10, 20, 30 use cases. In a 3-month exercise, I might end up with 30, 35 use cases in real terms. 2 business analysts working for 3 months. I'm just giving you a very, very rough idea. I go through all the singular common nouns to identify my business classes. So my actors also provide me an opportunity for business classes. I got my patient. I got doctor. And I have got appointment. Now I have many classes. I'll have as many classes as I want little chunks of programs in Java or C++ or Python or whatever it is. So I'm taking a quantum jump from requirements to classes. To reduce the quantum jump, I call them business domain objects, business domain classes, which are not programming classes. They will lead me to good programming classes. Now, this patient class will have 4 parts to it. 3 of them are visible: name of the class, attributes of the class, and behavior or operations. Any programming chunk will have data and something that works on the data. This is not rocket science. So in patient class, I will have data, which are called attributes. And I will have behavior, which are called methods, operations, functions, whatever, depending on the language. What would be 3 or 4 good attributes of patient?
Male or female, probably.
Okay.
Gender.
So
Gender.
name,
ID number perhaps.
ID,
Address.
Yeah, ID's good. You need a unique ID.
and following encapsulation, we'll have all of these as minus, right? Star UML by default will create attributes, pluses. Change them to minus. That's definitely a 1 mark out of 2. And I'm here to give away marks. Now, can you also tell me what are the 3 or 4 key attributes of doctor? And this is going to be very interesting.
They probably will have the same, they will have also some kind of identifier and a gender if we want to go. But then the
Skill.
specialties,
Gender,
yeah.
skills,
I would call the specialty.
Yeah, I agree with that.
specialty, yes. Will patient have something that is unique to them as well?
Problem.
Haha. So,
Affliction.
Ailment.
There you go.
Affliction.
hello.
Ailment.
This is ailment. Now this is a good designer, but we are not just good designers. We are great designers. So what are we going to do? From good to great. I think that's module 5, module 6, I forget where we study this. But Scott, with your experience, I mean all of us have experience here, but
I'm not a programmer.
This is not a programming question though. It will translate into program, but this is a conceptual question. Think, what would be from a good design to a great design?
I would create a generalized class, abstract class
Right.
in this case.
So what we will do, we will have a class called person,
No, but all the common under.
and you will put all the common attributes, name,
Oh, okay, so I was thinking creating more adopter objects
And
to
gender.
provide specialization.
and date of birth,
It
and
would be the
whatever.
other way around, yeah.
That's okay. So what you were thinking is called specialization. What we are doing is called generalization,
Yeah.
and both are based on inheritance.
Yeah.
Okay. So we don't need this, and we don't need this. Now we have actually saved a lot of programming effort, right? And we have created a small relationship called inheritance. Class design, not programming, just class design. In the solution space, we can move this into solution space. Another couple of interesting things. We have name and gender, we can have address, we should have an address. And my God, address, in the banking domain, there can be 30, 40 different types of address. My current address, past address, my joint address, my mailing address, my forwarding address. Ooh, it can go on and on and on. So, going from good design to great design, we will not put address as an attribute in person, we will take it out and make it a class. So, I have address, and I have a relationship, and then I will have, apartment, house numbers, street, state, and postcode, and whatever. And then so these are all minuses, and these pluses are going to activate. So it will be like create and delete are most common, but then you will have change address. Here you will have create and delete, of course, and then you will have more actions. Calculate age based on date of birth. Most common, calculate age. And you will say one person can have one address, which is a bad design. But this is called multiplicity. You put more rules, multiplicity, or in the ER diagramming it used to be called cardinality. But what it says is
One-to-one relationship.
and more than that.
A one-to-many relationship.
So what we are saying is how many, okay,
That's a
one
one.
person
Gross-
object,
gross
One to
notification,
many.
or notation.
Yeah.
one person, just let me finish this. One person object, which will not be a person object, which will be either a patient or a doctor. How many address objects can it have? And I'm using the word object now in a very technical sense, not a class. This is a class diagram. We are putting number of objects. One person will definitely have more than one address, but must have at least one.
Yes. That's
So
what
we want to
one
say
to many.
one dot dot n or we can also say one dot dot star, and you will find that in star. Now we look at from an address viewpoint. One address object can belong to how many persons?
Multiple addresses can belong to.
No, now we are going this
Yeah.
way. One address object.
Can be on
Now I and my wife could be living multiple
Multiple.
places. So
Many.
now our business rule is that will allow up to say must from 1 to say 8. And beyond that we break the rule. Or we have to have a extra qualifier. So whatever reason. I'm giving you a rough example. I'm not interested in how it actually happens in a hospital. Now what was your question?
Oh, it was not really a question, it's more of a remark. In SQL, they call that crow's feet notation. You have one to many.
And that
ER
is,
diagram.
and that was done by
Many.
Professor Chen. So they are also called Chen notation.
That's the ER
Chen
diagram,
notations
right?
are used in ER diagrams.
Yeah, ER
And the
diagram,
relationship, what's the difference between ER and this diagram? Now you are my great student. What's the difference? There's only one difference between this and ER. This is looking like ER, isn't it?
Yeah.
It's just how
You've
you
got
represent it.
relationships,
Right.
you've got attributes, so that I already now gave away the answer. What's the difference?
How you represent the relationships, right?
Okay, so that's the standard around it. But the key difference is there are no operations in ER diagram.
Oh.
Oh, yeah.
Right, yeah, that's right.
Good to know.
And that's where encapsulation and operations surrounding data comes in. Okay. I can also add to it that in ER we don't have inheritance,
Yes.
but we have association.
Right.
Yes.
And there is a special form of association where we are saying, like this room and the wall, person as an instance and the address. Whenever you instantiate person, you have to instantiate address. They are very closely linked to each other. If that happens, as in case of if I instantiate the room, the walls have to be instantiated. The association is so close that they are a part of aggregate. They are aggregated. So if person contains address, then on the person side, I slightly vary the relationship and it becomes an aggregation. So aggregation is a special form of association. We studied three relations. Inheritance, association, and a special form of association called aggregation. And we studied multiplicity, and we can always provide notes. We should always provide notes. I learned that from Peter.
What should we include in the notes? I mean, everybody includes different things, but in general, what is the best practice?
Best practice is to provide explanation surrounding the relationship because
Oh, the
the
relationships.
descriptions are usually clear,
Okay.
but the relationships need more explanation. And I provide relationship explanation. Also some suggestions to the programmers and things like that. I have seen people put entire data like a table description, which I would not do. But you can use notes quite judiciously. They are a formal part of UML notation and they are available to start using as well. Now, in the next 5 to 10 minutes, I need to hurry up slightly. We want to look at objects belonging to these classes. I'm a patient. You are a doctor. I belong to class patient and you belong to class doctor. Okay. And I have to check the appointment, the availability. Simple scenario. We did a flow chart. There is now one A patient, colon, patient. What does this tell you? Yes. A patient object belongs to class patient. But if it is A patient belonging to class patient, I can always just underline patient as an anonymous object and I can get rid of this whole big description. But let's understand that. And I have got a doctor. These are objects in the memory, and I'll further explain why or how. But first, I am sending a message to a doctor. I can always write here Google. I can always write here my. This is my timeline. In the timeline, I send a message. Booking available, I won't put a question mark, but this is a message to doctor. So guess what? If I send a message to you, what's your name? Your brain processes it and answers Murray. So you have the capability of processing the message that I'm sending to you. Therefore, all the code related to is available, I should say, in booking is available. Is the doctor available? Should be in
The method,
yes, which should belong to which class?
the patient class.
Why should patient know?
Oh, it's the
Oh,
doctor
right,
class,
method.
okay. The responding of the understanding of the messages that
Beautiful.
come.
Right.
Is that clear to everyone? I can repeat that one more time.
It's the
This is
patient class responsibility to answer back,
right.
or to rather to understand.
To understand the
answer
response.
back.
It's, so let's go a little technical now. This method, this message, let me be very, very clear, should be coded here as a method.
We don't code that, that just exists as part of the class.
Absolutely. And if you have to, I mean, we are not learning to code here in this entire code, but we should have the ability to specify the method is available, which will have a whole lot of code in Java or Python or whatever it might be, or C++, which we don't do. But we understand that when a patient sends a message, when I send a message to you, what is your name? You should be able to process it and respond. And the response is going to be like this. Why doctor? Because this is a response to this question. Not a fresh message from the doctor saying, why do you want to know?
Oh.
So let's clarify that. If the doctor were to tell the patient, why do you want to know? It will be a straight line, a straight arrow, not a dashed arrow. Because the dashed arrow is the answer to this.
Okay.
Now let's just blow this up a little bit more. This is what we call is available. Is available. What do you think will be inside the parameter list?
Boolean.
Boolean, yeah, let's reach there. But what, when a patient is asking a doctor, are you available for appointment? What do you think?
Yes or no?
So that's the answer.
No, time.
But I'm asking a question.
It's gonna be time, something.
Oh, okay.
Uh-huh. So let's, without worrying too much about the nitty-gritty, because we have already identified the doctor, we have got the doctor ID, and we have
Schedule.
a schedule.
Schedule.
And then here is your boolean.
Right.
And because all of this is implicit in the arrow, we don't have to show this.
Now, when we design class diagrams in STAR, you'll know I'm gonna have to get to that level of specificity there.
Yes, yes. And no, we don't. I know what I'm teaching. And I want you to know this. And all of you are my, including my recorded students, are all my A+ students. So it's you versus me. I want you to know this so you get better job.
It's getting fancy.
This is no big deal, Scott. No big deal. I appreciate the concern, but I want you to trust me. I'm the
Okay, we would
doctor.
love
I'm the doctor.
For the patients.
No, this is not a big deal, because there is so much to be done after this before you write your code, or when you write it. If you are a programmer, oh my God, there is a lot more to be
I've
done.
taken quite a few programming classes.
Yeah. But what I want you to appreciate is, if you are able to do this in real life, where you are given 2 weeks rather than 2 hours in my class, your end product will be very high quality. That's one thing. And second, you will have saves a lot of money, that is a lot of time for your employer, because you will not go down the wrong paths. And if you have to go down the wrong paths, it is better be here on a diagram rather than in code.
They must be like the whole path.
Now the last diagram is, so I'll show you just one more diagram and then we'll move to, is it still recording? I hope it is.
Yes, but it's flashing or something.
It's flashing
I
because
don't
the
know,
battery
it's
is
the
down. I
battery,
think.
probably.
Let me just finish
Okay.
my state diagram quickly because I'm not planned for this long, but that's fine. Okay. Now we have got patient object, doctor object. Now doctor object will be hit by many messages. Now if a doctor object is hit by is available and the response is yes, the doctor is available, and the patient says I want to book that appointment, how will I show it on my sequence diagram? This, isn't it? Book. Book the
And
appointment.
the book method will be on the document.
Absolutely. Now
Wouldn't the patient class have to have some understanding of that?
of
method?
course, what do you think? Yes, it
Yeah.
will be.
It has to know it's there.
Oh, of course. So, in patient class within the code, guess what? It will be a doctor dot
Oh,
book.
okay.
Even
It's
if
aware of
you
the
have
other
a-
classes
Uh,
method.
That's what.
Yeah.
So we will have an association between the two as well. Yes, yes, yes. I've been asking these questions 20 years ago, right? So if I am able to answer your questions, I'm not really very great person. Don't be impressed by me.
Okay.
Okay, let's go through the last diagram till the battery lasts.
Okay.
So doctor was available, right? A doctor, Murray, the doctor, was available. Then what happened? The booking happened, right? The message for booking hit, and the status changed to book. We need to know where to start reading the diagram, and we need to know where to finish the diagram. We are drawing a state diagram. What are these? Available and booked states belonging to, or no, you're right, the doctor, but the reason I hesitate it slightly is because it belongs to a doctor.
Oh, that object.
Yeah, that's
Right.
true.
That's
It's not
specific,
gonna,
Yeah.
Because
Why?
that could be a B doctor or a C
Yeah,
doctor.
that's specific.
So now a doctor is booked, and now Scott wants to book Murray the doctor.
Okay.
What happens? How will I show it here? Well, no, let's very, for hypothetically, let's say a patient tries a doctor, and a doctor is already booked.
Yeah,
So
to
a
try
patient
another
wants to
one.
book B doctor. On a sequence diagram, I can show this. B doctor. And the same, you check,
Call it
is
over.
available, yeah, and if it is yes, then you say book. Okay?
That's cool, okay.
Now, go back to the class diagram. Are you able to show A doctor and B doctor? No.
Because they're part of doctor class.
Structural behavior. Static, dynamic.
Okay.
So you will need 1, 2, 3, as many sequence diagrams you need to make sure that the class diagram is robust. So when that diagram is taken up by a programmer, which is again you and I, we are much better off than if we get directly coding. We are not doing programming. We can have another state diagram for B doctor, but doesn't make sense. My practical experience tells me one rich looking state diagram is okay. But whenever I'm available, I can have some states within that sub-states within that: drinking coffee, listening to music, and then I'm still available.